Hi, my name is Lynn and I am studying to become a B.C.B.A. In today's video, we're going to be covering class BEH 5043, unit number 8, which is titled Introduction to Data Analysis. This particular unit is also very visually heavy, so I won't be able to cover everything exactly because I'm just going to be describing visuals. Finding examples for these visuals may be a little harder than you'd think just because of the way they describe them, but they do go in great length to describe how to find certain items within these graphically important designs. So unit 8 basically starts off with the fact that in ABA, you want to let your data be your guide. If you are not taking data, you're not doing ABA, so data is a huge factor into what we do. We are in fact a science, right? We are here to study whether or not our manipulations will actually have a change in someone's behavior. That being said, we need to graph at all times. Our data, when we're given raw data, you cannot tell if there's a true change or how the change is occurring or when or specifically in what conditions or context it's occurring in without graphing the data. So they usually exemplify this by showing you just a table of raw data versus a graph of the exact same raw data, and you can clearly see changes in the graphs versus in the table it's just a series of numbers and your brain can't really compute what's happening with it besides the fact that it's just raw data. The purpose of graphing is so that you can assess your treatment and change anything if necessary. So there are two types of errors that can occur within your experimental data. There's false positive or a false negative. False positives usually occur when statistical analysis is sensitive to small changes versus a false negative where your visual analysis is too sensitive to large changes. So you get a false negative because you believe that there's nothing occurring when there's clearly a larger thing happening. Within visual analysis, there are two types of visual analysis that we do. One is formative and the other is summative. Formative is basically when you're looking at the data within phases and across phases while the experimentation is occurring. And then summative is when you've concluded all of your data taking and you look at the big picture. So formative is kind of when your head's down into the experimentation. Summative is when you step back and you see the full effect. So because of that, there are 7 steps that they describe to visual analysis. The first step is review the graph for standards. So how are you laying out your graph essentially? And are you making sure that your X and Y axis are in correct measures, so to speak? So if you're going to graph items over time, make sure you're graphing them consistently and that you have the clear markers for it. Number 2 is examine the research. Make sure that any previously done research, if there is available, also shows what you're looking for or can help you lead into a better way of how to go about your experimentation. When you're examining your research, you have to really think, what are you asking, right? Like what is your question with your intervention overall? Step 3 is determine if there is sufficient data. So when you're looking at your graph, is there enough data? Like usually they say you need at minimum 3 points. Some people say 2, but 2 is just a straight line. You don't really know if the trend is going up or down or staying flat. So they say a minimum of 3 points is generally what you want, but of course you want as much data as possible to show the most average that you'll get. Steps 4 and 5 are kind of mixed together, but that's because it says analyze your within phases and your across phases. So basically within phase and across phase, they are different in that within phases, you're looking at the data occurring within, let's say, treatment A, right? You're seeing like how often something's occurring within one intervention versus across phases, you're looking at 2 types of data sets. So like treatment A and treatment B put together, you're seeing the differences between those data sets. So that's within and across, right? So you just want to make sure that you have an understanding of those two. So because that was step 4 and 5 together, because it depends on if you're doing within, across, or both, then from step 6 in visual analysis is you want to analyze the consistency of change. So just because there is change in data, it doesn't mean that it's going to happen every time. And you want to make sure that you're finding consistent changes depending on the consistent exposure of your independent variable or your treatment overall, right? So if there's no consistent change, then there's probably something going on that you might need to look at so you can adjust for it and try to isolate any confounding variables or extraneous variables that may be changing your data so that your data is not coming out consistently. And then the last step is make a summative conclusion. So after you're done looking through everything that you have within your visual analysis, take a step back and look at the big picture, right? Step 4 and 5 was talking about formative analysis, which is the within and across treatment or phase, sorry. And then step 7 is summative, right? So you're looking at the bigger picture. From there, you want to make sure that you're looking at when you analyze your data, you're looking at your level of data, right? So do you have sufficient change within your data to make any sort of claim? Is there a noticeable difference? Are there not enough differences? Did you change between the phases too quickly, or did you not have enough data in between them? So you want to make sure that you're looking for the right level, right, of it. And the level of your data will be a flat line across what is the most amount of data, right? So if you have 5 points of data, and they're all going within, let's say, points like, let's say there's like A, B, and C. Most of them are going around B. Then your level is going to be there across the B section. Like I said, this is a very visual unit, and I can't really get around that, so I'm just going to try to describe it as best as possible. But just remember that your level is going across the most data. And then from the visual analysis, we're also looking for trends. So we have level of your data, and then we have trend. So trend either increases, decreases, it has zero or flat trend, or has no trend. The zero trend versus no trend is kind of difficult to explain, but let me see if I can describe it. So increasing and decreasing are fairly self-explanatory. Increasing data means that your data is going upwards, right? So it's following a particular trend, and if you draw the trend line, your data is going to be going upwards, right? So level always goes across the most if it can, but it always stays flat. Just imagine level means level, right? But trend always follows what direction your data is going to. So as far as increasing, it will go up. For decreasing trends, most of your data points will go downwards. For zero or flat trend, they'll stay kind of in the middle. But then let's say for none or no trend, they compare that akin to like if you have a parabola, I think, where it's basically an upside down U. So there's no real trend there because it's going both up and down. So it doesn't seem to be affected by your intervention regardless of what's happening. Something else is happening, right? Because of this, you want to be aware of cyclical patterns. Remember, going back to schedules of reinforcement or time like hormones or even time of day when you eat, right? So those cyclical things can occur and create either no trend or a flat or zero trend, or conversely, it can increase or decrease data, but only during that time frame. You also want to pay attention to the immediacy of trends. So how abrupt was the change when you implemented your data, and how much overlap is there between the data between phases? If there's more overlap between your data, it doesn't necessarily mean it's good. It could also just mean, like there's definitely something that is occurring that may not actually be your intervention that's affecting the behavior. From there, it discusses PND, or percentage non-overlapping data. So you want to look at the percentage of data that overlaps, that works with what you're looking for, or it doesn't overlap. So from there, they discuss the types of ways you can measure that. They have something called the split middle method. Once again, I'll just describe it. It's not something that can easily be noted per se, but they do go over this in the unit over a couple videos of describing how to measure for it. But the split middle is basically, it's a conservative estimate, and it plots the trend line, and it compares the trends between conditions. So basically you're looking at the data, drawing the trend lines, and looking at what direction the trend lines are going. And from there, it discusses a stability envelope as well. So the stability envelope is when you draw the median line, which is in the middle, right? And then you draw parallel lines, a certain percentage above and a certain percentage below that particular median line. And you calculate the percentage of data that falls within that stability envelope, because you want to see how much of the data stabilizes among the average, and you want to see where if there's too many changes, maybe your data is not actually as valid as you want it to be. The only issue with this particular one is is that it tends to have an arbitrary percentage above and below. So the example that they had was for one stability envelope in a particular published study, they had a 2% plus or minus from the median line. And then for another one, they had like a 15 or 20% above or below, which kind of makes you question the bias of the data, because the percentage for the stability envelope itself varies, and like I said, they're arbitrary. There's no written rule as to what you're expected to do. From there, it goes into a dual criteria, which is a refined split middle method, which once again you're looking at the trend lines, and you are carrying the trend level lines from one condition and you're overlapping it to the adjacent to kind of measure and see how much of a difference there is. This reduces type 1 error, and you're basically trying to overlap the data to see how much is truly being overlapped. Once again, it's using that split middle method, and you're comparing the trend lines and you're seeing by how much is the variation or the difference between those conditions. This is used with a table. So the percentage that you discern is usually associated with a table from Fisher et al., which was published back in 2003. Again, this is a very visual unit, so they use these tables to show you what to measure and how to measure it. But one thing that was made for certain was if you use this method, reference Fisher et al. 2003 and use their table to discern how valid the data is that you are comparing and determine if a systematic change has occurred or not. So after that, the unit covers what's called a conservative dual criteria. So it's similar to a regular dual criteria, which once again is that refined split middle method. So you see it's all accumulating. But basically it's same as dual criteria, except they use a 0.25 theta adjustment to measure the differences from what you've determined from the dual criteria. So that is to say, when you measure it and you compare it to Fisher et al.'s table, you're constraining the data to make sure that you're following a more stringent path of analysis. It's basically an improvement upon the dual criteria. So it needs to be determined still with Fisher et al.'s table, but it is a more refined, more exact version of it. So that is something, if you want to use that, you can use that. I should mention that with these items in place, with these different types of data analysis in place, I've never heard of anything like this from any of my B.C.B.As I've talked to. So I don't know how effective this particular type of measurement or data analysis is used or how often it's used, because when I've mentioned like a dual criteria or the conservative dual criteria, my B.C.B.As are like, oh yeah, I remember learning about that, but they don't actually say, like, oh yeah, I use that all the time. So it really is dependent on what you're doing, because I got a feeling this is much more in the research line rather than the practice line of ABA. So just bear that in mind when you're like stressing out over how effective or how much you're going to be using this stuff per se. That being said, the conservative dual criteria, when used effectively, does reduce both types of errors. That is, it reduces false positives and false negatives very effectively. So that's why it is a improved upon version of previous data analysis methods. So it's better than the dual criteria, which is better than the split middle method. So just keep that in mind. For that, you want to make sure that when you are analyzing your data, that you are analyzing for consistency of change, numbers of replication, so how often can it be replicated or how often did you replicate it to maintain that consistency of change. And from there, the whole purpose of data analysis is to determine experimental control, which once again is determining, is there systematic change in the environment solely based or resulting in predictable change in behavior. So when you change the independent variable, how much is it changing that dependent variable? So that's the whole point of data analysis. So when they boil it back down to that at the very end of the unit, I do remember them saying like, this all feels like a lot to take in, especially since they start doing things like with a lot of math. In the unit, they even joked about like, I suck at math. I don't know what a theta symbol is supposed to mean, but really they're trying to say, just remember, regardless of what method we're using, we're just trying to determine how effective these interventions are and if we need to change them in order to create a better outcome. That is the whole point of data analysis within ABA. So just don't get too lost within the nitty-gritties of data analysis and just make sure you remember what you're doing in the first place with it. That being said, if you have any questions, please let me know in the comments down below. I'll see if there's there's any visuals with the split middle methods and the dual criterion. There was some available, I remember, online, but I don't remember if they're still there, because they are, once again, it's a bit different than what you usually see with ABA, but there might be some available online. And then if I made anything incorrect, if I said anything incorrect, please point that out in the comments below, and I can definitely post an addendum either in the description or make another video. And I hope I was able to explain Unit 8 with what little visuals I could provide, but I hope it's not too confusing for you. Until then, I'll see you in the next video.